Have you ever looked at a friction force and thought, should it point left or right? We often say friction always opposes motion. That's a great shortcut, but it's only part of the story. If you stop there, it's easy to draw friction in the wrong direction. So today, I want to show you the full version. Friction opposes the relative motion, or the tendency of relative motion, between two contacting surfaces. Most mistakes happen because people forget two key ideas: relative motion and contact. In other words, don't ask which way the whole object is moving. Instead, look at what happens at the contact. How do the contacting surfaces move relative to each other, or tend to move relative to each other? Let's put that idea to test with two examples. First, let's look at three stacked books. This is one of those problems that give a lot of students a headache. A person pushes the bottom book to the right, and all three books move together. Let's find the direction of the friction forces. We'll start with the top book. The top book is only in contact with the middle book, so the friction force on this top book comes from that contact. Now ask yourself, how would the top book move relative to this middle one, or tend to move relative to the middle book? Since the books are moving together, there's no relative motion between them. So we need to look at the tendency of relative motion. Imagine the friction between the top and middle books suddenly disappears. The middle book would move forward with the bottom book, while the top one would tend to stay where it is because of inertia. So relative to the middle book, the top book would tend to slide backward. To oppose that tendency, the friction force on the top book points to the opposite direction, which is to the right. Now let's move to the middle book. This is where the problem becomes more interesting. The middle book is in contact with two different books: the top book above it and the bottom book below it. That means the middle book has two different friction forces, and we need to analyze each contact separately. First, let's look at the contact with the bottom book. Imagine the friction between the middle and bottom books suddenly disappears. The bottom book is being pushed to the right, while the middle book would tend to stay behind. So, relative to the bottom book, the middle book would tend to slide backward. So the friction force on the middle book points to the right. Now look at the other contact, the one between the middle and top books. We already found that the friction force on the top book points to the right. But this time, we are looking at the friction force on the middle book, from the middle book's point of view. So let's use the same method again. Imagine the friction between the middle and top books suddenly disappears. The middle book would move forward, while the top book would tend to stay behind. So, relative to the top book, the middle book would tend to slide forward. To oppose that tendency, the friction force on the middle book points to the left. Notice something important here. The middle book is moving to the right, but one friction force on it points to the right, and the other points to the left. So simply knowing which way the middle book is moving tells us nothing about the direction of either friction force. We had to look at each contact separately and ask, how would the two objects at that contact move relative to each other, or tend to move relative to each other? That's what determines the direction of friction. And there's one more important point. At the same contact, the relative motion depends on which object you are analyzing. If we are analyzing the top book, we ask, how would the top book move relative to the middle book, or tend to move relative to it? If we are analyzing the middle book, we ask, how would the middle book move relative to the top book, or tend to move relative to it? Same contact, but a different object of interest. Now let's look at the bottom book. The bottom book also has two contacts. the middle book above it, and the table underneath it. Let's analyze the contact between the bottom and middle books first. We're looking for the friction force on the bottom book. So again, imagine the friction between these two books suddenly disappears. Relative to the middle book, the bottom book would tend to slide forward. To oppose that tendency of relative motion, the friction on the bottom book points to the left. Now let's look at the contact between the bottom book and the table. In this case, the bottom book is actually moving forward relative to the table. So the friction force from the table opposes that relative motion. Therefore, the friction force from the table on the bottom book points to the left. So the bottom book has two friction forces, and in this case, they both point to the left. So what we can learn from this example? First, one object can have multiple friction forces because it can have multiple contacts. Second, each contact has to be analyzed separately. And most importantly, don't look at the motion of the whole object. Look at the relative motion or the tendency of relative motion at each contact. And remember, the direction depends on which object you are analyzing. The same contact, different object of interest, different relative motion. That's the key to finding direction of friction. Now let's look at a more surprising example. A car accelerating forward. Which way does the friction force on the tire point? If you are thinking the car is moving forward, so friction must point backward. That's exactly the mistake we are trying to avoid. So let's go back to our method. Where does this friction come from? It's the contact between the tire and the road. Now ask, how do the tire and the road move relative to each other, or tend to move relative to each other? Imagine the friction suddenly disappears. The driven tire would spin, and the bottom of the tire would tend to slide backward relative to the road. So to oppose that tendency of relative motion, the friction force on the tire points forward. The car is moving forward, and the friction force is pointing forward. And that's not a coincidence. This friction force is actually what makes the car accelerate forward. You may be thinking, isn't it the engine that makes the car move? Well, the engine provides the power that makes the wheels turn, but the wheels don't directly push the car forward. The tires push backward against the road, and the road pushes the tires forward through friction. And that forward friction force is what accelerates the car. Notice what determined the direction of friction. It wasn't the direction the car was moving. It was the relative motion or the tendency of relative motion at the contact between the tire and the road. So whenever you are trying to find the direction of friction, remember, don't just look at the motion of the object. Look at what happens at the contact. That's where the direction of friction comes from.